Okay, can you see my screen? Is it visible?
Not yet.
Okay, let me share my screen. Okay. Okay, now can you see my screen? Yeah.
Yes.
Okay. So,
Yes.
yeah.
Scan.
Yeah. Okay, let me open a code editor. Okay. So first of all, okay, we discuss about that crop types classification. So how we can easily classify the different types of crop, okay, using our ground truth data. So further, I try to use this result and discuss about how we can easily classify the different types of crop, okay, such as rice, then cotton, then fodder, then maize, then sugarcane, then wheat. So any kinds of crop we can easily classify it, but for that we need the ground truth data, okay, for this type of crop. Suppose for this classification, I just already use some ground truth data in this result, such as I take some ground truth sample for the rice, then cotton, then fodder, then maize, then sugarcane, then wheat, and further I simply apply the machine learning model, random forest, and then we try to classify the different types of crop. Okay, so let me show you the theory part, then I discuss about the practical, then you will get the idea. Okay, let me open my slide. So today I discuss about that crop type classification using machine learning with ground truth data. Workflow for crop type classification with ground truth data. So first of all, we need to prefer our ground truth data. Okay. Suppose how I can prepare my ground truth data. So first of all, we need to collect the field survey data. So crop type label with GPS point, mainly latitude and longitude. Or we can also draw the polygon also. But it also better to use the GPS point, mainly latitude and longitude. And this latitude longitude with their label. Okay, we need to set the label. Suppose for the latitude longitude, I find out the one, suppose rice. So I set the label for rice. Suppose I set the label 0. 0 is for rice. Then I set the another label, suppose 1. 1 is for suppose maize or sugarcane or any other types of crop. So in this time, first of all, we need to collect the field survey data and crop type level with GPS coordinate, latitude, longitude, and level. Three column we need. First column latitude, second column longitude, and third column the level. So level basically it stored the different types of crop level. Suppose for the rice I set the 0, for the sugarcane I set the 1, for the, so we simply set different types of level, and level can be more than one, no problem. Okay, so we can set suppose similar level. Suppose you have lot of data for the rice, so we can simply put the same level for rice, 0 0 0 0 0, all of 0 it indicating about the rice. Suppose then 1 is indicating about the sugarcane or other types of crop. Okay, after that collecting the field survey data, so this data we need to upload as a shape file or geojson file or csv file. Basically in Google Earth Engine we can upload shape file as well as you can also upload the csv file. Okay, suppose I prefer a csv file. This csv file I including all of latitude, longitude, and level, 3 column latitude, longitude, and level, and then I simply upload the csv file in Google Earth Engine, and further I can also work with that. And then each feature should have geometry. Basically we need the latitude, longitude, it indicating about the point, and also crop type attribute. Suppose for the rice I set the level 0, for the wheat I set the level 1, maize set the level 2. So this crop type attribute and also geometry. So each feature should have geometry and crop type attribute when you use the ground truth data. After that, we need to select the remote sensing data. Okay, suppose in this case we set the multispectral or also SAR. Basically the Sentinel-1 SAR data is also help you to identify crop types. Okay, further I'll also discuss about that. But today I discuss about the Sentinel-2 and Landsat 8 and 9. So Sentinel-2 is the 10-meter resolution, we already know. And optical, we can easily find out all of band reflectance value, as well as we also created different types of indices, NDVI, EVI, or NWI, or others. And this type of NDVI, EVI, or NWI can also connect with our model, and further we can also make the classification. Okay, and Landsat 8 long term, when you analyze the long term analysis, suppose very first time, then we try to use the Landsat 8 and 9, or Landsat 7, 5 for the long time. And Sentinel-1 is very helpful basically for cloudy region. Okay, so when you apply this type of study area, when we find out the lot of cloud, suppose my cropland all time we find out the cloud, then we try to apply the Sentinel-1 SAR data, because it's very better work in the cloudy region, we find out. Okay, very better image for the Sentinel-1 SAR data. And we also identify crop structure. Okay, different types have the different types of structure we can easily identify using the Sentinel-1 SAR data. Okay, so after selecting the image collection, remote sensing data, then we need to feature engineering. So in the feature engineering, we need to add some vegetation indices for the different types of vegetation indices as a feature. Suppose NDVI, okay, normalized difference vegetation index, or EVI, enhanced vegetation index, or soil adjusted vegetation index, or water difference index. So this type of thing we also add in here, as well as we can also add the phenological feature. Okay, phenological feature mainly time series mean value, median value, standard deviation value. So this type of value we can easily get the phenological. Suppose start of season, peak of season, end of season. So we can easily identify this type of value. So when it will be high, when it will be low, or average value, median value, we can easily get. As well as SAR package scatter value. So when you work with SAR imagery, so then we can easily use VBVS band if Sentinel-1 is included. We can also add this type of band. As well as we can also extract the different types of topography data. Suppose DEM, slope, and aspect. This type of data we can also add. So when you work the more better classification, extract the feature from the DEM data, slope data, aspect. So we can easily use this type of things and also create the feature. And finally, suppose I create my data, and finally we need to spill the data. Suppose 70% data to train my model, and 30% data I just use for validation, and we take the data randomly. Okay, randomly stratified spill to keep the class balance, and then we spill the ground truth data. After spill the ground truth data, simply apply the different types of machine learning model, random forest, support vector machine, gradient boosted, or also deep learning is also help you to more work. Suppose for the random forest, we can easily apply, works well with the multispectral data. Okay, and support vector machine is good with the small data set. Suppose when you work with a small data set, then we can easily work with the support vector machine. And nonlinear separation, we also use the support vector machine. And gradient boosting or XG boost, also light GBM. So these are powerful for structured data. We can also use. And deep learning, basically your convolution neural network or long term memory. So this type of thing we also use LSTM or CNN for time series crop mapping. Okay, or hyperspectral data, we also use this type of deep learning model. And also classification, use this type of classifier. And finally, we can simply train our machine learning model on ground truth data plus satellite bands or indices, and apply the classification to the full imagery. Okay, and to create the map. Further, we also check the different types of accuracy, contribution matrix, overall accuracy, kappa coefficient, or F1 score per class. This type of things we also computed, and we can finally represent our result, or also calculate the area. So if you check, I will show the one code which I already done in here. So okay, just let me open. So here I already make the analysis and try to classify the crop for this point using the ground truth data. So here you can see we create this type of, so this is only for the crop types of classification. So here we find out this type of green color indicating about the maize crop, then this type of color indicating about the cotton or fodder, this type of color. Okay, also sugar cane, you can see this type of color indicating about the sugar cane, or white, red color is the wheat. So this type of crop, how I can classify it using the machine learning with the help of ground truth data. So today I try to discuss step by step, then you can easily get the idea. So first of all, we need to, this is our study area. So this is our study area or shapefile boundary. So for this boundary, so in this case, I take the whole Punjab area. So it's called the Punjab, and whole Punjab area I want to classify it for only for the crop. Okay, but in this Punjab area we also find out the different types of other features, not only for the cropland. It also have the build up, it also have the your water body, it also have the also suppose grassland, okay, or also trees, or different types of other feature without crop. Okay, we also find out in this study area. In this study area we also find out different types of other feature. Suppose build up, we also find out that suppose grassland. Okay, we also find out that suppose trees or forest, as well as also barren land. So first of all, when you work with large scale, suppose I need the crop types classification map for the whole Punjab area. So first of all, we need to classify this type of classes. Okay, and then we simply remove this type of classes. So in this case, first of all, we need to make the classification for build up, we need to make the classification for suppose water body or barren land or other classes. Okay, first of all, you need to make the classification for the other classes. So for that, if you check here, I also add the barren land. So I take the training sample for the barren land. I also take the training sample for the urban area, then water, then forest, and also grassland. Because this type of class is not including with the crop. Okay, so that's why we simply separate. And if I don't separate, then what happened? Then this type of grassland or forest land also mix with my crop result. Okay, so that's the main region. I just simply separate and make the other class. So for the study area, I simply classification for the barren land, urban, water body, forest, and grassland. Okay, so I simply make the take this type of training sample from my satellite images, and I simply make the separation. So that's the region. When I make the classification, then this type of forest or grassland or other class is not mixed with my crop pixel, is not mixing. So let's go. I will try to explain one by one, then you can easily get the idea. So first of all, I simply make the classification. So here you can see, here I already run, and if you check, so here I already uploaded my training sample, mainly crop training sample. If I just show you the print and show you the result, suppose print this agriculture. So this is my CSV file. This CSV file I already uploaded in my Google Earth Engine asset tab as a CSV. In this CSV file, if I show you the result, what I got in this file. Okay, so you can see it through the feature collection. So in this feature collection, we find out total 1390. Okay, 90 training sample, and this type of training sample I collect from ground. Okay, and if you check all of information, all of feature, suppose I just click on here, then you can check this is the point. So I take the point, and if you check the properties, so here I find out the properties is the 0. Okay, it's my level, so I set the level 0 is for rice. Okay, in this case I set the 0 is for rice. After that, if you check, click on here, this is the another property, it's the class 1. Okay, so this training sample I just use the another crop types. And if you check what is the last training sample, if you check, so you can check, this is the another training sample, and it for the class 5. So class 5 I just used another crop ground truth data. So this is the file. So in this file, mainly it is stored different types of crop with their attribute, mainly with their level 0, 1, 2, 3, 4, 5. Okay, I set the label 0, 1, 2, 3, 4, 5. So all of crop. Okay, all of crop, sugarcane, maize, rice, we try to add in here. Total, this is our class 5. Okay, total 1390. Okay, training sample. And this is our CSV file. In this CSV file, I will show you the one example. Suppose in this CSV file, basically this type of CSV file, it's not. Suppose this type of file, suppose latitude, longitude, and also find out that suppose your level, 3 column. Okay, so let me create the another file, then you also get the better idea. Suppose I have this type of CSV file, and here I including, suppose this is the latitude, then long, and also level. So then I simply put the latitude, longitude, and also put the level. Suppose level 0 is for rice, so I put the all of 0, it's the rice, and also put the latitude value and also longitude value. Okay, latitude value, longitude value. Same as, suppose I put the 1 is suppose another crop, 1 is suppose sugarcane, so I put the 1 1 1 1 and also put their latitude, longitude for each crop land. Okay, same as, suppose I put the another crop for the 2 and also put the latitude, longitude value for this crop. Okay, suppose 2, this is another crop, 2 2 2, and also put the latitude, longitude value for this type of cropland. Same as like for 3 suppose for another cropland, so I simply put the 3 3 3, so this is the level, and I put the latitude, longitude value for this type of cropland. Same like as for suppose 4, suppose for another crop, so I put the label 4 and also put the latitude, longitude value for this type of crop. Same like as for 5, and also put the latitude, longitude value for this type of crop. And finally, suppose 6. So any types of crop we simply put, and then simply put the latitude, longitude value.
Sir,
Yeah, please. Yes.
sorry. So normally when I collect the ground truth data here, I normally use a GPS essential. Do you know it? GPS essential.
Yes.
In mobile phone, the GPS which is installed in my mobile phone.
Yeah.
And normally we collect through the waypoint. When you want now to create the CSV file, I must try to write manually, or there is a way of extracting from the mobile phone.
Yes, it also possible. It also possible. So some tool or some mobile application we also use to collect the ground truth data. Okay, suppose we simply set the level, then it automatically create the CSV file. Okay, suppose one is the called the Kobo toolbox we also use. Suppose this file, if you check, so we also use this. It also available for
What?
that. It's a Kobo toolbox. So let me show you that Kobo toolbox. Kobo toolbox. So this is the one kind of tool, okay, to collect, analyze, and manage the data for
Yes.
survey or modeling or evaluation. So you also try to use this Kobo toolbox tool, and then you also take the training sample. Okay, then it automatically create the CSV file. Okay, Kobo toolbox. A lot of tutorials available in the YouTube how to we can collect the data or collection data or process the data. So you also try to,
Also it.
yeah.
Okay.
So this Kobo toolbox you also use,
Okay, sir.
and
Thank
further you can also collect your training sample, and then automatically we can convert this training sample as this type of CSV file. And further simply upload the CSV file. Otherwise, manually when you do it, it takes a lot of time. So that's why it's not the proper way.
Yes.
So we have just use the Kobo toolbox and collect our training sample from the ground. Okay. Okay, so now suppose I take the training sample, and here I find out this type of total this type of, you can say I simply uploaded different types of crop with their label. So my data collection part is complete. Okay, so now I simply show you the data from the ground data. We simply upload it as a CSV file. Okay, and then I simply display this type of data. Suppose just a map.add layer. Suppose I put here map.add layer and call the agriculture. This layer I simply call, and then I just display this type of training sample on my map, just on the code. So now it's loaded all of training sample or point, which I upload it in my system. Okay. So you can see this is my training samples. Okay, and we take the training sample, you can see. Okay, so we can make the clustering basically, so we can see all of training sample, not much far gap. Okay, you take the lot of training sample, okay, for this land. Okay, then it will be look more better. Suppose I simply visit a field and I take that lot of training sample from this field, lot of point I just including. So you can see for the one field, you can see we take the lot of training sample. You can see suppose this field, you can see. So we can take the training sample, lot of the 1 2 3 4 5 6 7 8. Okay, so lot of training sample we try to keep in here. Also you can see 1 2 3 4 5 6. Okay. Okay, so this type of training sample we simply connect and it's come from our ground. You can see this type of training sample for the different crops. This is another cropland. We take the training sample. So now we just apply this training sample with our machine learning model, and then further we try to make the classification result for the whole study area. Okay, whole Punjab area we try to classify. And if you check this study area have also some build up area or settlement, you can see it's a build up area. Okay, or also some area have some forest area, also have some water body area or barren land area. So that's the region we also try to classify this type of barren land, urban, water, forest or grassland. So and we simply just simply distinguish between our cropland and this type of classes. Then this type of class is not mixed with our cropland. Okay, and we find out the more better accuracy. Otherwise this type of pixel, suppose grass pixel, forest pixel, water pixel, barren land pixel also mix with our classification result. Okay, suppose we mix with the rice, sugar cane, then it will also hamper our result. Okay, so now we take the training sample. So now we just work with satellite image collection. Okay, so in this case it also depend on your season, because different season cultivated the different types of crop. Okay, suppose for the different season, okay, it also vary region to region. So in this time we find out the total 3 season. Okay, we find out the total 3 season for my study area. Suppose here I find out the one season, it will be start in 2017, suppose January to February. Okay, for the January February it create the one season. Okay, so for that what can I do? I simply take the time period January to February and also filter my image collection for the Sentinel-2. This image collection is simply filtered between this time period, and we take the less than 10% cloud cover, because very short time we take for the season January to February, and select this type of band. Okay, b1 b2 b12 band, simply select, and you can see we simply create the median composite and clip with our study area. So then further we try to display our imagery. If you check, we simply create the imagery for the first season. Okay, January to February, so it's one season. This season it's cultivated for a specific crop. Okay, so okay, so we find out this type of imagery. If you check this imagery, we find out, so it's one kind of imagery we also find out in here. You can see, so this is the one image for the specific season, suppose only for the January to February. Okay, this 2 months create the one season, and we create this median composite and make, and same process we also apply. Then you can see March and April we create the another season and create the median composite. Okay, create the another season and create the median composite, and same process we apply and create the another, suppose May June we create the another season and create the another composite, and same process, this is the another 2 season, we just simply composite. Okay, and same process we create, this is the another season, just composite. Okay, this is another time period. So this region, or it also vary region to region. Okay, I can see we simply just create this type of composite. After creating this composite, all of image, suppose image 2, image 3, image 4, image 5, image 6, so basically this type of image is stored the different season images. Okay, suppose in this time after creating the composite, Suppose you can also combine all of season, all of image, we simply combine. So in this case, we just combine image 2, image 3, image 4, image 5, image 6, which is indicating the different crop. So we simply just create a collection. So, and if you check how many images in this collection, just print, check, and run the code. So we find out the 5, okay, 5 image collection. We find out in this collection after combining. And now this is my image collection. And for each image, suppose I find out total 5 images, and every images I want to calculate the NDVI, mainly normalized difference vegetation index, I want to compute. So for that, we create a function. Suppose this function help me to compute the NDVI from every image, this image, this image, this image. So every image, it help you to compute the NDVI. So for that, we create a function. So if you check, we simply create a function. And this function, we simply connect with our image collection. Okay, simply connect. So in this function, I simply take a element name. Suppose I take the element img, and using this element, we simply compute the NDVI. Okay, and this NDVI we return as a bands. So simply return image at bands with the NDVI. So now this function is stored all of image with their NDVI result. If you check the NDVI result just from the code, we find out that all of image also stored the information of NDVI. Just check, click on here, you can check. We find out that it is stored all of bands, and we also added the new bands. If you check, this band is the ND. ND basically NDVI. Okay, default show the ND. If you check, we find out the all of bands, added the new band of NDVI. So in this case, I just show the one example only for the NDVI. But in this case, you also add the different types of bands to get the more better map. Suppose NDVI can also add, you can also add the EVI. Okay, you can also add suppose SAVI. Okay, you can also add suppose another different types of vegetation indices we can also add. Okay, as well as NDW you can also add. So okay, so you can also add the different types of band, not only for the NDVI. So when you add this type of EVI, SAVI, or also you can add the another ZCVI. Okay, it's very powerful. So this type of other vegetation indices you also try to add in here. Same process, add. Then this type, suppose I want to add the another one. Suppose I want to add for SAVI in this equation. So what can I do? So very easy. Just you simply take a variable, suppose SAVI, and then call the img and apply the normalized. So just simply check the SAVI formula. Simply search here. Suppose SAVI formula for Sentinel 2. Simply search. Then we can easily get that soil adjusted vegetation index. Okay. So this is the one kind of formula, SAVI. So you can check the result. So SAVI near minus red divided by, so this is the formula. Soil adjusted vegetation, near is the embedded. Okay. And the correct band from near infrared even near specific Sentinel 2 dataset. Let me check. Applying the same formula Sentinel 2, we try to apply this formula. Now just I simply copy this formula. Let's check from here, I can see. They also provide this type of formula. Or this is the formula. Okay. So let's go try to apply. This is my formula. So just apply the expression to compute this type of long formula. Expression and put your equation. So my equation is Bennett minus band 4, okay, then divided by band 8 plus band 4 plus 0.5, okay, and then this equation we need to multiply. So for that, simply use here the parenthesis and also close this parenthesis and then multiply this value 1 plus 0.5, okay. So now simply use the comma sign and define what is the near, what is the b8, what is the b4. So same process, put here b8, so it's come from this image and select the band b8, and what is the b4, just simply define b4, so it come from this image and select the b4, okay, and after it's a constant value, so it's okay, no problem. And further you can also put here that dot rename and put the name, suppose Savi, okay? And finally put here the dot add bands. So every time when you add the new band, you just use that function add bands and call this variable name and paste here. So now it create the band Savi. So you can same procedure also have to calculate the EVI or GCVI, and this type of indices we can also connect with our model, and then we can just make the land use crop types classification. Then it will be provide you the more better result or better classification. It also help you. So now if I run the code, what happen you can see. Just run the code. So now all of image collection, it also added the new another bands. This band name is Savi. Okay. So this is the way we can add the more different types of indices. Okay, for that. And after that, we simply, you can see just I simply two bands. So it's another function. So what the function about the two bands? So if you check, let me show you the from the description. So in the image collection, I simply use the function, this function called the two bands. So you can see e.image collection. I want to apply this two bands function only for the image collection. You just click on here. So this function convert a collection into a single multi-band image. Okay. So suppose in this time, this function help me to convert a single multi-band image containing all the bands, every image in the collection. Okay. So in this case, if I show you the result, suppose just we simply use the two bands, and then I want to just simply map dot add layer of this img. So now what happened? So this function helped me to convert all of single multi-band image, okay, containing all the bands for every image in the collection. So now run the code and check the result. So you can see it added the all the bands, it added in here, you can see. Okay, it's added all the bands, 1 2 3 4, this one. Okay, just click on here, then check. So you can see all the bands we find out in here, you can see all the bands, okay, containing in this image collection, all the bands. So if you want, you can also display it manually. Suppose single band you also try to display. You can see this is the different types of band we can easily show. If you were just click on here, then you can find out only for the single band also display. Okay, so this two bands function convert the multi-band image collection, okay, and containing all the bands in this image collection. Okay, and further it display the layer. So just it's optional, I simply put, and we already display the points. Okay, suppose just I display the points again, just run the code. So this type of training sample, just display again using the red color. You can put any color. And after that, we need to merge all of training sample together. Okay. So how I can merge this type of training sample together? So further you can see I take the merge water, merge with forest, then urban, then agriculture. Okay. Then merge with barren land, then merge with grassland. So now if you check, I take the training sample for the barren land, urban, water, forest, and grassland. And if you check the label, what is the label for that? Label is the 6. Okay, it will be start from the 6. Then you can see what is the label. Label is the 7. Okay, 6, 7. Then you can see what is the label. Label is for 8. 6, 7, 8. Then 9. It's a 9. And finally, it's a 10. It's a 10. Okay, so you can see I started from level value 6. Okay, because my agriculture, this CSV file agriculture, it stored the level 0 to 5. Okay, 0 to 5 for different crops it is stored in here. So you can see I already show you the result. So it is stored different types of crop from 0 to 5. If you check the first item, the property is the 0. So 0 is the one types of crop, it can be rice. And you can see what is the last property. This last property is that class number is 5. Okay, it's another cropland. So 0 to 5 I used for the different types of crop, and it come from my CSV file. You can see it's a 5. But when I take the training sample again from my satellite images, help of geometry import, then I take the training sample, it will be start from the 6. Because I already set the level 0 to 5. I already set this level for different types of crop. 0 is one crop, 1 is another, 2 is another, 3 is another, 4 is another crop, 5 is another crop, and I take the 6 is for barren land. And this training sample I collect from my satellite imagery. Okay, I take this training sample from the satellite imagery. Same process for urban. Okay, this 6, then 7, then 8, then 9, and then 10. Okay, just I take the training sample, this type of training sample, I just collect from my satellite images, help of different types of band combination, and identify and take the training sample for the different classes for barren land, urban, water, forest, and grassland. Okay, and 0 to 5 I take the training sample from my CSV file. 0 to 5 it is stored the different types of crop. Okay, and 6 to 10 it is stored other class. 6 to 10 you can see 6, 7, 8, 9, and 10. Okay, we take the training sample, and finally merge. You can see we simply merge. Okay, simply water, merge, forest. So all of training sample simply merge. So then check how many training sample we take. Just print the sample. So when you find out that, you can see how many total sample. This is the total sample, 1984. Okay, 1984 training sample. It's including all of training sample. Okay, it's including all of training sample. Suppose it's this training sample, some training, I take that crop land or agricultural land training sample, I just collect from the CSV file, and other training sample I just collect from my satellite imagery. Okay, so this is my training sample. So further, this training sample we are just use as the prediction bands. So further I simply take a variable prediction bands and I call the image. Okay, so from this image I just simply put the band names. So now if I just print, you can see what happened. So just I use the print, this variable is stored all of bands. Just let me show you that just on the code. So band names function, it displays all of bands which is indicating in your image. So you can see it create the list all of bands. So you can see list total 45. So you can see, so all of bands, okay, for every season. Okay, so you find out in here. And finally we are just simply connecting this band. Yeah, please.
Why I don't see the created bands, NDVI, survey?
Yeah, we also
When you
add
print image.
we add this after some time later. Okay, we try to add the later after some time.
I don't see when you print image dot bench names. I don't see it listed there. If this IMG variable does not store those NDVI, you see.
Oh, okay, we need to add it. Yeah, we need to add this band also. So it just show the result
Yeah.
B2, B3, B4, B6, B7, B8, B9
Yes.
and for the 0. Then okay, so 1, 2, 3, 4, 5, 6, then also 3, then 4. Okay, total 5 images we have. So it added all of the span without NDVI. Okay, so let's go try to add.
Yes.
So we already create a function. So this is our function. Okay, this function is simply connect with our, then this type of band also added with our is images. Okay, so this is the variable. Okay, in the screen. Okay, let me try just a copy. This is my function variable name. I want to connect this one.
We have to connect this ADVI file. We have to connect with IMG to create new variable.
So this it stored the all of collection image. This variable is stored. Yeah.
Yes.
And this collection, okay, this thing I already connect, okay, with my NDVI result. So this is my function
So we have
variable
to
name.
use.
Yeah. So this function
We have
variable
to use.
we connect
We have to use NDVI here.
in here.
We have to use.
Okay, just I use. Okay, object is
Sir.
yeah, please.
Instead of using IMG, I think we have to use NDVI FIN. Because this NDVI FIN stores all the bands and all the created indices.
Okay, okay, and apply the two bands.
But yes.
Okay.
Yes.
Okay, now it's working. Yeah.
Also, okay, yes.
Yeah, you can see Savi and N2.
Yes, yeah.
Yes.
Yes.
You can also add the more, suppose ND and Savi or others. Then you can also put the name NDVI, so then it will look more pertinent. Savi and ND. So now you find out that all of bands connecting with our image collection. Okay, and this type of bands were used for our training our model. Okay, so further we simply take a variable, another variable, training image, and then I just call the prediction bands from this image. We simply select them to flood. So now run the code. Okay, it also works. There is no problem. So float basically take that your decimal number also. Extract from here.
What?
Decimal number 1.2, 3.5, 0.33. Okay, so when you apply this, then it will convert this type of things. Also take no problem. And after that, we simply apply the.
Sir, please.
Yeah, please.
Not yet get you about that float function. We take AMG, we select the predicted bands, is it?
Yes, 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 yes.
What does float?
So plot basically it also, if you check, I will show you that from here. Okay, float.
Float is a decimal number.
Yes. So you take that, pass the input value to 30-bit float. Take one kind of decimal number, we just simply took in here. Okay, so after that, we find out the bands. So now we need to extract the band pixel value from our sample. Okay, we already make the sample. It is stored all of training sample. Okay, so now we try to extract the pixel value. So further, we just use a function. It's called the sample regions. Okay, we already knew about the function sample regions. So as we simply put the sample region and call our train image, and it's select with our prediction bands, and then sample regions. In this time we simply put the collection our sample basically destroyed all of training sample, okay, including agricultural land and also including all of barren land, urban, water, forest and others. Okay, and property, you can see same property class. Okay, same property for the class, because when I take the training sample, I put the column name class. Okay, you can see I put the column name for the class. For every prop land I put the class 0. Okay, suppose basically this column name, uh, in my CSV file I put this column name is the class. Okay, I put this, it's a class. Okay, so then I just keep the same level. Okay, I put the class. So that's why I can see when I take the training sample from my satellite image, I also put the same property is the class, but value is different because 0 to 5 we already use for the agricultural land, different types of agricultural land, and then put the scale and others. Then this data set, if you check, okay, let me show you that result. Just print the classifier training, just copy and run the code. And then if you check all of training sample, so now just check all of training sample from here, from the feature. So you can see we find out the all of values, all of pixel value. So we simply put the randomly distribution, okay, because we select the random. So just take a variable with random, and we just call this data set and put the random column. Okay, then just put the random column. So after that, we simply filter this data roughly 70% and 30% for the training and testing. Okay, put the training and testing randomly 70% and 30%. After that, we simply apply the classifier. Okay, so I just call the random forest. Okay, this random forest I am to apply, and then I just train my 70% training data, and simply train, and this train data is simply classified, okay, with our image. And further we also check the random forest train error matrix. I will check the accuracy. So now on the code. Okay, so we find out this type of accuracy for that random forest train accuracy, random forest train kappa accuracy, and this is the error matrix. Okay, because in this time we classify total 10 class, 0 to 10, but 0, 1, 2, 3, 4, 5 it's our specific crop. Okay, 0 to 5 it's the specific crop, but 6 to 10 it's the other class. For the 6, what is that? Barren land, urban, water, forest, and grassland. Okay, then further we try to display our image. So now first of all, we try to display for that your all of class. Okay, so this map is stored all of class, total 10 class we find out, including all of croplands as well as also including all of training sample, croplands and others features, barren land, urban, water, forest, and grass. Classification. Okay, so in this classification it including all of classes, total 10 classes. Okay, but in this case I don't work for the all of classes, mine is for agricultural land. So just I simply remove this type of classes: barren land, urban, water, forest, and grass, mainly 6 to 10 all of class I simply remove. I just keep only 0 to 5. 0 to 5 is indicating only for the crop, different types of crop. So for that we simply filtering or removing this type of others. So for as well as check the test accuracy. Okay, so just I simply show you the result. This is the test accuracy. Simply connect our testing data and then check the test accuracy. Random forest test accuracy. Run the code. So now it display about the random forest test accuracy. Rest of the 30% data. So it including about that performance level of your model. For the test accuracy, we find out that. Okay, it's working. So it's computed the your random forest train test error matrix, then random forest test accuracy, then random forest test kappa accuracy. We can easily find out. So that means we find out this type of test accuracy. Okay, so you can see test accuracy is not good. So that's the region we need to also add more bands. Okay, not for that SAVI and NDVI. You also try to add the more bands. Suppose EVI, NWI, okay, or ZCVI to get the more better test accuracy. Okay, from this map. Okay, so now we simply we simply remove all of training sample, mainly all of classes. So further we simply take that classification. This is the variable. It is create this full map, land use, land cover, which is including total 10 classes, but I simply put the less than 6 and max, take the variable max. So further we simply take it. So just take the crops, update max. Okay, so and we simply put the crop classification. Just run the code. So we take the only for this level less than 6. Less than 6 basically 5 to 0. Okay. And we simply update marks with and pick the variable crop. So now we find out the another layer which is indicating only for the crop land area. So if you check. So this is the random forest classification. It's including all of classes 0 to 10. But this crop classification it just show the result only for the 0 to 5 and which is indicating the different types of crop land. So now again so we find out. And others, suppose other barren land, urban, water, forest and grass, automatically automatically remove this type of classes. Find out this type of land you can see for the different types of crop. And others classes, suppose barren land, water body, or also your build up area, this type of class is max. And we find out this type of crop land. Further we simply add the legend and display the result. Okay, 0 is for rice, then 1, 2, 3, 4, and 5. It's loading. and you can identify this type of props. So this is the one process. This process you can also apply for also Landsat and Sentinel-2. Okay, with this type of satellite imagery, we can also apply for the Landsat or Sentinel-2. We can also apply. And now we talk about the Sentinel-1 or SAR data. Okay, so I hope you also get the idea how we can easily apply the multi spectral satellite imagery classification help of ground truth data. Okay, so you also try your own data and then further check the result. So now we talk about that another, suppose SAR data. Okay, this is the multispectral data you can easily apply, but Sentinel-1 SAR data for crop type analysis is very good result, because Sentinel-1 SAR data can capture information independent of cloud cover or sunlight. Okay, so affected by Sentinel-1 SAR data. So that's why we can easily get. So let's try to explain this method also. Then you can easily get the idea how to use Sentinel-1 data and also Sentinel-2 and also Landsat data. Both of that we can easily use, as well as another data we also use for it's called the your embedding satellite data. So it's very powerful. So Alpha Foundation it also provide, suppose embedding let me open it. So this data is very powerful data set. We also use it. Okay. So this is satellite embedding. Okay, it's also available from this time. Okay, and you can see the 10-meter resolution. There are a lot of bands. So you find out in here, total 64 bands. Okay, total 64 bands, and it easily more clearly identify different types of cropland. We can easily identify. So further class we discuss about that how to use this data, and there are a lot of uses. Okay, for the agriculture section. Okay, so it's a newly updated data set, and it's combined all of data set, Landsat, Sentinel-2 or SAR data. Okay, is 10-meter pixel data set, total 64 dimensional embedding vector. We find out in here. Okay, this is the Alpha Foundation, produced by Alpha Foundation. Okay, this data is we can also use for the different purpose for the agricultural precision. So far they also discuss about that how we can easily use this data. So now let's talk about the Sentinel-1 SAR data, how we can easily use and then make the crop types classification. Okay, let me just show you the result. So let me open the code editor. As I was just we talk about that Sentinel-1 SAR for crop types, crop type analysis. Okay, so for that, first of all, it's basically we find out this VV and VS polarization, and it's very sensitive to crop structure, to crop structure, also biomass, and also soil moisture. We can easily identify. Okay. High frequency. This is another benefit. I revisit frequency. Okay, basically in the 6 to 12 is 12 days. Okay, and another very powerful is that it's penetrate. So this is the best benefit to use the Sentinel-1 SAR data. Ideal for monsoon or cloudy region, you can easily use it. Okay, and we can also use it to make the your time series of crop phenology analysis, and also classification and crop mapping. This type of things we can easily use the Sentinel-1 SAR data. So let's go. First of all, we need to define our study area. So take a variable, suppose AOI. Suppose I have a rectangle, latitude, longitude value. So I want to import. Okay. So for that, you can simply use the EE dot geometry dot rectangle. It's not work right. EE dot geo. Okay, let me check the function.
Small g. Case. It is lowercase.
Okay. Geometry. Okay, just a minute. Okay, I think I need to reload this site again. Just a minute. It's not connecting the server. So that's why function is not showing the purple color. Just a minute. So take a variable AOI EE dot now you can see it okay. Yeah, EE dot geometry rectangle. So now we simply define a list. Now I take the 89.0, then 23.5, longitude, latitude, then put the longitude. So it was 90.0, 24.5. So now let's say we try to show our study area. Map dot layer AOI, and of the focus map dot center object is AOI, and run the. So this is our study area, suppose. Yeah, so for this area we want to identify crop types using Sentinel-1 SAR data. So now further simply call the load the image collection. So for that simply copy this snippet ID and paste, and then give a name. Suppose I put the name is S1, and then filter for our study area. So for that, just take a variable, suppose put the filter bounds function with my study area, which is AOI, then put the filter date. So I put the time, suppose cropping season. Okay, suppose 2023 06 01 from 2023 10 01. So cropping season. After that, I want to simply filter the instrument mode. So just I put out the filter and put here Earth engine filter dot equal. So I want to filter in instrument. So instrument mode is here you instrument mode. Okay, and put at the IW. You can also get this type of information from here. Image properties. So you can see instrument where is instrument mode? Yeah, instrument mode. Yeah, so this one instrument, we can use the IW, interferometric wide swath, extra wide swath, and a strip. So it is the IW. Okay, so it's very popular, we use all time, interferometric instrument mode. Okay, so after that we need to filter the transmitter receiver. Okay, transmitter receiver, basically we try to select the band. So for that, put here the dot filter, earth engine dot filter. And this time I want to filter list contains. So list contains, and I want to list contains. I just put the transmitter receiver, or check the bands, or image properties. You can check this transmitter receiver polarization. Then I put band name, I put VV. Same, also do for the same for the VIs. Just I copy the same line of code and paste here, and I put here that VIs. Okay, transmitter receiver polarizer is set, and also put the your orbiting pass. Okay, orbit pass. So put here the filter again, and earth engine dot filter dot equal. I want to put here orbit pass, orbit properties passed. You can check orbit properties passed. Yeah, this one. So basically ascending, descending. So I put the descending. Okay, descending. And finally, we simply clip with our study area. Just clip. And in this case, you can see if I just use here the clip function, it will be problem. You can see. Suppose I will show you the how many images. First of all, suppose print S1 and apply the size function and run the code. 36 images we find out. Okay, for this time. And I want to clip all of images. Okay, so in this case, you can see if I just put here the dot clip function and clip with AOI, it a problem. You can see we face a problem. Suppose I want to add the layer, so then it show a problem. Map dot add layer and call the S1 around the code, it show a problem. We find out this type of problem. Okay, so I want to clip all of images. Okay, I want to clip all of images. Suppose I have how many images? We check total 36 images. S1 dot size. So you can say how many images we find out. We find out total how many images? Just a minute. I find out total 36 images. So I want to clip all of images. So now what can you tell me what the function I need to use when I use the 36 image clip? Any idea?
So yes, we can use median.
No, in this time I want to, without creating median, mean, or without creating the composite, we just simply clip
Yes.
all of images. Suppose I have total 36 images. I want to clip all of images without creating median, mean, or mosaic.
Yes.
So for that, we just create a function. So in this time, I create a function. This function helped me to clipping all of images. So let's go try to create a function. So I want to apply the clip all of images. So we create a function. So I put the function, suppose function keyword, I put the function value name is that, suppose I put the name is img. And now what is my argument? My argument is that all of
Function
images.
name.
So for that, we simply take a variable. So I want to return this element clip with AOI. Okay, and this is my function. This function I connect with my collection, 36 image collection. For connecting, use add map function. Yeah, please.
Function has no name.
Please.
The function created has no name.
Why?
Function any argument with that function has no name. Maybe function.
No.
Function name.
In this
function
time,
name.
okay. So now we try to use the same variable name. Okay. So you can see the same line of code. We just connect with the same variable. So I create a function. So this is my function, and I just connecting with this same variable. Just use the map. So this thing basically stored my collection, 36 image collection, and this collection I simply connect with my function. So now you can see without clipping function, I can add display my map. Okay, it show this type of map without if you check
without median.
Not median. So it's just show all of without composite. Yeah, without composite, we just clip all of images. Okay. So now for that, if you check, suppose I want to check the band, specific bands, and then stressing, suppose 98%, and then apply. So now we find out this type of imagery from here. So this is the one process. Without creating mosaic, we can also use the clip function, but for that we need to help of function, because at the same time total 36 images I want to clip with my study area. So that's why we simply create a function. So now this image we need to pre-process basically speak all filtering. Okay, so it's called that speak all filtering. So let's try to discuss about that, how we can easily filtering the image for Sentinel-2. So pre-processing the image.
Please.
Yeah, please.
We can also add we can also composite the 36 image and proceed with this. It is possible.
Yeah, also same.
Okay.
Suppose after clipping you can simply apply dot median. So then it clipping all of 36 images and also create the median composite. Okay, and when you done the clipping, so then after creating the median, don't need to use the clip, because you already complete this process for clipping.
Okay.
Yeah. Okay, so now we pre-processing the image. For that, we need to speak all filtering. Or it also called the reduce noise, mainly reduce noisy pixel. Okay, and radiometric correction is already done. Okay, radiometric correction is not need. Radiometric calibration done, already done in GE. Okay, so it's not need. And also train correction, sometime it already applied. Okay, so but when you work with other, then need this type of correction, train correction we need, but this train correction already done in GE, so that's why I not need to for the train correction. So now we are simply convert to dB scale value. Okay, so if you check the bands, so this type of bands value is simply convert into dB unit. Okay, so dB unit we need to convert this type of band pixel value. So speckle filtering and radiometric decibel, radiometric calibration done, already done, then train correction is already done. So now we simply applying the speckle filtering and also convert the dB scale. So for that, we just take a variable, suppose 2db, and then we just create a function. Suppose I put the function name is img and put the curly bracket. So for that, for the dv, normally we are just take the value 10. Okay, so I return, but this is another process for the SQL filtering. So I hope you can also learn about that flood mapping in our 7 number class. In the flood mapping, when I pre-process the Sentinel data, I try to add the full function for pre-processing the Sentinel-1 SAR data for the flood mapping when I discuss about that. Because flood mapping, when I discuss, then I discuss about that SQL filtering. Okay, very long code we need to add for the SQL filtering. But in this case, we normally take the value 10 and then convert the dv. Okay, so for that we simply put the return and ee dot image. I put the normal value 10, and these things multiply with image logarithm log 10, and after that apply the copy proper and apply all of images property names. Okay, so this is the function. This function I want to connect with my image collection. So I put the variable s1 and then call this collection. I put the same s1. I take the same variable s1 and then put the dot map function and connect this function variable and paste here. So basically the normally we just use. So now we can extract the your different types of feature. Okay, suppose we need to extract the some pixel value such as VV or VS or VB by VS ratio. Okay, VB by VS ratio. So for that, first of all, we calculate the ratio. Suppose VB by VS. So take a variable. Suppose I put the variable name is the ratio, and I call the S1. I create a function. Suppose for that function keyword, and I just I take the element image. So now what is my argument? My argument is that I want to compute this ratio. So for that, just take a variable. So I take a variable, suppose VV, and call the image and select the band of VV. Take the another variable, suppose VS, call the element name and select the VS band, VS, and then we simply return. What I return? I want to return this VV divide with VS. Okay, and then I rename it. Suppose dot rename. I put the name. This band name is VV and VS ratio. Okay, I put this type of name, and this thing I want to apply all of those images. So put here the copy properties, and apply all of images, and also mention image property names. Okay, so now it's a function. I just simply connect with all of images. This is the S1. Just take copy and connecting with my function using map function. Just put at the dot map and also close this parenthesis. So now you compute the ratio. Okay, ratio. And so now in this case, we simply put our training data. Okay, so in this time, suppose for this place, I have some training point. So this training point I want to import. If you want, you can also import the CSV file, no problem. And directly you can simply click on and import the CSV file, or if you want, you can also take the some point randomly you can write, or also import the CSV file. Suppose I take a variable props. So this variable I just put all of props. I just create a feature collection. This feature collection I add some different feature of prop. So put here ee dot feature collection. Okay, so in this feature collection I want to set some feature. So first feature. So put here EE dot feature, and I want to create a point of latitude longitude. Put here EE dot geometry dot point. Okay, and I can put the latitude longitude value. Okay, suppose in this case I put the 89.5. Suppose I randomly put, but when you work you can just put the accurate data. So I put at suppose 89.5 longitude. Then I put here suppose 23.9. So I point out this is the one crop, and I put the property. Suppose I set the column name is the class. Suppose this is the price. Okay, so same, I create the another, I put the same, copy this same line of code. So this is my training sample. Okay, so just I simply take the two training sample at this time. But if you want to get also more when you work with the practically. So I put this is the latitude longitude for 89.7 and 23 point. Suppose I put the 8, and I put the class. Suppose this is the class for wheat. So then you can put the other crop, suppose rice, sugarcane, or different types of crop for with the different. Okay. So this is my feature collection. Okay, this is my training sample for ground. So I just assigning the level for the different types of crop. So rice, sugarcane, or wheat. Okay. So now we simply stack the feature. Okay. Suppose we simply create the median composite. So just take a variable. Suppose I put the variable name is composite and call the S1. Okay, and then apply the, I create suppose median, and I want to add the bands. So his band I want to create ratio. So this one I want to add. So for that just apply a function add bands, call this ratio, and for this band I want to create the also same median. So put at the median again. So now let's check, we try to display. Oh my god, it show a problem, too many argument image dot compute the natural algorithm for the input. Okay, so I will try to show you the later for that proper way to compute the DBS scale. So now we try to compute the composite without DBS scale, and we find out this type of median composite. So just I simply and display. Original display suppose VS ratio. So we find out this type of visualization. Just import. Okay. Okay, and if you check our training sample from here, just add. Okay, so suppose this is the random training sample. We just put rice and wheat. So this is our training sample. But when you work, you take the more training sample from your CSV file or also take. So now we're simply applying the machine learning model and compute. And it also more better if you want to classify the other classes. Okay, same process, I already show you this process in here. So simply separate some other classes, suppose barren land, urban, water, forest, or grassland. It will be more better for the crop types classification. Otherwise it will. So now I'll show you that how we can easily apply. Okay, so for that we find out this is our composite imagery. Okay, so now we need to create the training sample. Okay, so we need to extract the pixel value. So take a variable, suppose I put the variable name is training, and call this composite. So from this composite I simply store it the information using the sample regions function. Okay, and put here sample regions, suppose collection. It's mainly your props, different types of props, training sample collection. And then put here your properties. So set the property property is the class. Okay, because you can say I put the property name is the class, it's our column name. So after the property we need to set the scale is 10 meter. So further just print and check the training. So if we can check, we find out only two training sample. We just simply extract the pixel value. So if you check total 5 properties, we find out the VV, PS, angle, class, and also ratio. Okay, we simply add PS, VV, angle, class, and VS ratio for the 2 training sample. So this is my property. So I need to use this type of property and then apply the machine learning model, and then further make the classification. Okay, so other process keep the same. Suppose for the same process just simply apply, create the classification. Okay, create the model, random forest or others, and then we simply apply. So let's go and try to show you that.